Question 30C. The diagram shows the location of 3 schools. School A is 5 kilometres due north of School B. School C is 13 kilometres from School B. And angle ABC is 135 degrees. So part 1. Calculate the shortest distance from School A to School C to the nearest kilometre. Now, looking at this diagram, we have a triangle, we have 2 known sides and an included angle. That means it's cosine rule. So let's use that. So we need to find AC. So the cosine rule goes AC squared is equal to 5 squared plus 13 squared minus 2 times 5 times 13 multiplied by the cosine of 135 degrees. So let's work that out. We're not going to round it until the very end. Okay, so we have 5 squared plus 13 squared minus 2 times 5 times 13 multiplied by cos of 135 degrees. So AC squared is equal to 285.92388816. But we want AC. Okay, so just like with Pythagoras theorem, we need to take the square root of the previous answer. Okay, 92388816. So square root of our previous answer. Okay, and we get 16.9. Okay, however, we need to round it to the nearest kilometre. So 16.9 is equal to 17 kilometres to the nearest, correct, to the nearest kilometre. Okay, so I'm going to add this on to the diagram. Okay, so that's 17 kilometres. Let's have a look at part 2. Determine the bearing of school C from school A to the nearest degree. So this means that we need to find school C, the bearing of school C from school A. So we actually need this angle here. Okay. Now, from north to south is 180 degrees. So we actual fact, we need this angle there. Okay, angle BAC. So I'm just going to put a theta there. So if we can find that angle, we can add it to 180 degrees, we get the bearing. Okay. So this means then that we may have to look at another rule. Now let's see if we have some side angle pairs, because maybe the sine rule could work here. We have 17 kilometres opposing 135 degrees. So there's a known side angle pair. We have theta opposing 13 kilometres. So there's a side angle pair where one of the, the distance is known, which means that we can then use the sine rule to find theta. So let's do that. Okay. So, and we need to find an angle. So I'm going to write it this way. Okay. Sine 135 degrees over 17. Okay, so that's sine 135 over 17. Okay, that's a sine A over A is equal to sine of theta over 13. Okay, so that's sine of theta over 13 kilometers. Let's solve this. Okay, so sine of theta. Okay, I'm going to move the 13 over to the other side. So that's going to be 13 multiplied by sine 135 degrees over 17. Okay. And theta is equal to the inverse sine. Okay, so we don't want sine theta. We actually want just theta on its own. Okay, of all this. Okay, so 13 multiplied by sine 135 degrees over 17. Okay, so let's quickly work that out. So shift sine. Okay, and in fact, I'll do it this way. 13 multiplied by sine of 135 over 17. Okay, close brackets. We get 32.73. Okay, I might just, okay, 32 degrees, 44 minutes, in fact. Okay. So the bearing, okay, of C from A is going to be 180 degrees plus that angle we just found. Okay. okay, of C from A, okay, is equal to 180 degrees plus 32 degrees 44 minutes. Okay, so let's add 180 to that, and we get 212.733 degrees. Okay. Okay, but we need to round that to the nearest degree. So that's equal to 213 degrees, correct, to the nearest degree.